The goal of this lesson is to put you ahead of the curve to make your code far more flexible than others. There are two concepts that will deepen your object-oriented programming understanding: mixins and composition. Previously, we talked a lot about the is-a relationship in inheritance. So a common paradigm is to say, for example, that a bus is a vehicle is transportation. But what happens when you have a bus that's been converted into a home? It's still a bus, but it's not really a vehicle anymore. In this lesson, we'll refine our understanding of inheritance in object-oriented programming. To understand why we need refining, let's dive into the circle ellipse problem. This section will require you to think hard and depends heavily on your understanding of the previous lessons. So if you need to, grab water or take a stretch break first. First, recall from school that a circle is an ellipse. To jog your memory for why this is, an ellipse has two axes, where each axis can have a different length. A circle is a special case where both axes are the same length. So, a circle is a special type of ellipse. And we say that a circle is an ellipse. However, recall our is-a rule from the inheritance lesson. A is a B if A has all the properties that B has. So, plugging in what we know, a circle is an ellipse since a circle has all the properties that an ellipse has? Hold up, that seems really wrong. Circles don't have all the properties that an ellipse has. A circle only has one axis length. An ellipse has two axes lengths. So if we really think about it, an ellipse has all the properties that a circle has. Therefore, an ellipse is a circle. So our teachers were wrong? Turns out this isn't right either. A circle has a radius, but an ellipse does not. So ellipses don't have all the properties of a circle either. So I suppose a circle is not an ellipse, and an ellipse is not a circle, at least according to the is-a relationship in inheritance. Our solution is to use a different paradigm called mixins. I think of this as the can relationship. Let me show you what I mean. Here are two classes, person and dog. Beneath both classes, I've listed their methods. We'll start by using inheritance. Our natural parent class is living thing, which defines move and grow by default. Here, the gray text under person and dog means those two classes inherit those methods. However, what if we add a car class? A car is not a living thing, but it can move. Let's create another parent class for classes that can move. This new class is called movable, and both living thing and car inherit from it. Great! But what if we add a plant class? It's a living thing, but it doesn't move. There's no clear hierarchy where this will work. So instead of building a hierarchy using inheritance, let's consider what each class is able to do. Each parent class instead defines a property of the object. Here, we have a parent class for all classes that can grow, called growable in pink. We also have a separate class called movable in blue. Each parent class defines a new behavior that the subclasses can do. A plant can grow, a person can move and grow, and so on and so forth. So in summary, A can be if A has the ability B. For example, a person is growable since a person can grow. The official name for these ability-based classes are mixins, which greatly improve the flexibility of your code. You can mix and match any number of different abilities for each new class you define. Another alternative to the is-a relationship is composition, where we nest objects instead of inheriting objects. Composition is summarized by has-a relationships, like how a car has wheels. I believe composition has more nuance than most online articles cover, but we'll stop here for now because I feel the nuance will be more confusing than helpful. We'll cover the nuance of how composition replaces inheritance in a later class, post, or video. Our final concept in this lesson is polymorphism. In short, polymorphism is when several classes all implement the same interface. In other words, a set of classes all satisfy the same expectations. For example, we may implement multiple animal classes, like monkey and dog, that all have grow and move methods. Say you have a piece of code that only relies on the grow and move methods. Then the cool thing is, you can run that code on any animal class you have. That concludes our concepts for this lesson. In short, we covered the circle ellipse problem to unveil a flaw in is-a relationships. We then covered two alternative types of relationships, can and has-a relationships, to improve the flexibility of your code. Finally, we briefly discussed a benefit of object-oriented programming, which is polymorphism. For a copy of these slides and more resources, make sure to check out the course website. This concludes our Advanced Inheritance lesson, leveling up your object-oriented programming understanding. This was a challenging lesson, so if you didn't quite follow, that's okay. The tips and takeaways from this lesson will make more sense as you begin to use object-oriented programming and begin to run into design flaws yourself. In the next lesson, we'll implement mixins.